I'm here at useR 2014 with RStudio founder JJ Alaire. Thanks for taking some time.
Absolutely.
So you have a pretty glorious history in the world of computing. You've invented a great many things. You're famous for a great many facets of computing, from the web all the way now to data science and R. Can you talk to me a little bit about your role at RStudio and why you decided that this was your next venture?
Yeah, I actually, before I got into computing, I was in social sciences. I was in political science and economics, and I was very interested in quantitative analysis. I was very interested in the intersection of computing with quantitative analysis. And I actually went to graduate school in political science and found that not so many people in the discipline were interested in that. And I found myself, more and more interested in computing. So I sort of ended up with a career in computing, even though I had sort of started off wanting to be in social science and data analysis and this sort of stuff. And so I heard about R probably about 6 years ago, and I was sort of between things, and I kind of knew that I wanted to work on open source software for the rest of my career. Really, I wanted to work on things that had durability, that could be around for 100 years. And so when I learned about R and reflected upon sort of the things that got me into computing in the first place, and the fact that R was open source, it was very natural for me to want to work on R. And there's lots of things to work on with R. It's a really interesting environment, and I started with working on the IDE because I felt like an environment that supported people writing R code and doing data analysis with R was a really good one. Hadn't been built up yet, and so I thought that was an important role that I could play.
So that's interesting that you went right for durability.
Yeah.
So R, as we heard in the keynote this morning, has basically roots, 30-year roots.
That's right.
But when you look at it, it did have this sort of lull in popularity, much like a lot of my favorite programming languages. They were consigned to being toy languages, or very domain specific.
Yep. And
to a degree, I'm relatively new to R. One of the things that brought me to R was the RStudio IDE.
Right.
So how do you feel that the creation of an IDE and the creation of this entire support framework for new people is going to help with the durability?
I think that the fundamental durability comes from the fact that R is open source, and then the second tier of it comes from the fact that it's widely embraced, and so there are lots and lots and lots of packages and libraries that are built around it, and lots of other pieces of computing are integrated with it, and that helps reinforce the durability. I think the fundamental piece is open source. I think the making it easy to learn and approach, and making people who are doing data analysis in R, highly productive, is an important part of its. I'd say it's not fundamental to durability. I think it's fundamental to adoption.
Okay.
It's fundamental to success, and those things, adoption and success, tend to reinforce durability.
Sure. It's funny that you go to adoption. When I was first exposed to R, I was not impressed. As a traditional computer scientist, traditional computer programmer, I didn't see the value in it. And it's only once I switched my mindset to this entire idea of working with the data in the environment interactively.
Right. Yes, people don't. R is an interactive data analysis environment, right? It should be thought of that first, not a programming language first. I think John, in his keynote, made that point very, very well. That what they were trying to create with S was a really great interactive environment for exploration, experimentation, quick feedback. So a lot of things that in R, even a lot of the way evaluation works, a lot of it has to do with the fact that the expectation is that users are invoking these commands at a console where they're looking for a reply, rather than working in a programming language where they're, I call a function, I get a data structure, I compose that data structure with another data structure, and then yet another one. That's the traditional way of programming, and that's not what people are doing in R. So, and I think it was also really, John made the point that, there are computer scientists who are looking like, how can we make R faster and a better programming language? And his point was, that's great that you can do that. That is actually not the point. They already had a real programming language in the form of Fortran that they were basing everything around, and now we've got the same sort of thing going on with C++ and distributed computing things. There's lots of people doing heavy-duty computing, heavy-duty computation, leveraging all the power of the hardware and all the most modern programming environments, and then that's all made available in R in this interactive data analysis environment. So
the entire data process, right? It starts, you load your data, and that's its own world, is getting the data into a loadable format.
Yep.
And then there's this exploratory process of visualization, doing quick modeling and really playing with the data. And then there's the concept of, then it goes into production.
Mm-hmm. Yep.
And I think that a lot of the cognitive difficulty that people have is that they don't understand that those are such separate tasks.
Yes, that's right. Yep.
That the tool set that allows you to explore is not the tool set that you'll necessarily want going into production.
That's right.
There's a big, right now the tension probably, and I don't know if you'll agree with this, is there's a dynamic tension between the R community and the Python community.
Yep.
Those would be the two big open source communities that are trying to do this. So you chose R.
Yeah.
Why not? Why was that?
I chose R because it was a language and an environment that was tailored to and purpose-built for its task. And I think for people who don't I would say by and large, users of R do not self-identify as software developers. Mm-hmm. They say, I'm an economist, I'm an analyst, I'm a scientist, I'm a statistician. And so for that group of people who don't self-identify as software developers, they're looking for something that has zero impedance and zero friction with their thoughts, right? And so whereas someone who identifies as a software developer, comes from a computing background, says there are certain things in a computing environment I'm looking for as a baseline. The
biases you bring.
And then it's great then that I can take that baseline and combine it with some domain. But they really value those staples of computing and computer science and programs. But so it's a different. I think R, for its audience, is ideally designed. So, and I think you see that some of the tension. I think people who come from a computing background, it doesn't make sense to them, and they might be more attracted to an environment that comes out of computing and computing science. But I think in terms of building systems that people use effectively and understand and are extremely high productivity, I think R has a pretty significant advantage.
Well, I agree, it's my primary environment for a reason.
Yeah.
So at RStudio, you guys have built not just the RStudio IDE, which is its own, I mean, to a degree it's a technical marvel. I mean, it is built using web-based technologies. It can be deployed either on a single machine or it can be deployed with RStudio server.
Yeah.
But there's a lot of other things that you guys are not just developing, but sort of fostering the community around. Can you talk to me a little bit about sort of what are these projects that are not just the ones we know about, but what is the future?
Yeah, I think that one of the things as we worked on the IDE, we really started out just working on the IDE, and then it's a process of learning and observing what other problems are people trying to solve, and problems have to do with statistics, or we have not that much to add, although we've grown our team and we've got folks that are statisticians that know a lot about data visualization, and so we have more of that now. But when we started, I'd say our background was more computing and computer science. But we observed certain things that people were repeatedly trying to solve, like how do I publish artifacts of R analysis on the web? How do I build web applications with R? So with those, a couple of things that we've worked on more recently, like the work with R Markdown and the work with Shiny, have to do with us saying, well, we've got some experience with web environments and web computing, and now I think we understand R and the R user well enough that we can compose some interesting solutions, and that's a place that we can make a distinctive contribution, whereas we're not going to make a distinctive contribution in in the statistics piece of
the underlying statistics.
We're not, so I think we're sort of attracted to problems that we can make a difference solving, and then I think it gets into, then you have all these pieces and you have this IDE, and then how do we how can these things be composed together in a way that it's really easy for people to get on board and learn? And so I think that's, you see more investments now of us trying to integrate things in a way that makes it easy, really very easy for a person starting out with R to immediately, okay, I'm doing data analysis and now I'm publishing things to the web and now I'm building applications. I'm using version control. It's in the Coursera course that's going on right now is teaching all these things. In a sequence of courses designed to start people from not knowing anything about R. They're teaching version control, they're teaching reproducible research, literate programming, they're teaching Shiny. So they're teaching all these things, and I think part of it's aided by the fact that you have an environment where it's well integrated and easy to understand.
I'm enrolled in that.
Okay.
I'm actually enrolled in the Johns Hopkins course.
Yeah, that's what I'm talking about.
Data specialization. It's fantastic, but one of the things that I've noticed is that I don't think it would have been possible pre-RStudio.
Yeah, we hear a lot from people who teach, and in fact, the initial users of RStudio were teachers. All of the initial users were teachers, and I think that I think you're right that I would say the biggest contribution there is because fundamentally what RStudio does is it's not different from using a text editor with a terminal and an X window. I mean, it's a similar thing that's going on, but the user needs a conceptual map of what's happening. They need to understand there's various pieces that are in play and they relate to each other and I can see them all at once. And I think one of the things that RStudio tries to do is articulate what's there, articulate for the user what's in R, so they sort of have a conceptual map of what they can do, what's possible, what they can inspect. And I think that really aids in initial learning.
I was talking about this with somebody earlier. My 13-year-old son, a teenager, has actually become interested in the world of data analysis by seeing RStudio on my desktop. Wow. It has allowed him to have intuition about what I'm doing, which he did not have as a computer programmer.
That's right,
So I think about him, he's a 13-year-old, no formal mathematics background outside of middle school. And yet he's interested in RStudio, he's interested in it now. What is your target audience? What is your dream audience for these, to consume these
It's an interesting question. I think that what we started with was fundamentally, I mean, we could see when we started that R was incredibly popular, that it was incredibly compelling to people, just as it was, without RStudio. That there was a huge critical mass. So I think for us to say, if we can serve the people who are already using R, that's fine. We don't need to think about who else can use R and how can we extend it to other domains. And so I think that's the foundation. But I think what we've seen is that and the learning curve for someone, for example, who's not familiar with data analysis tools or uses Excel, there's still a pretty big learning curve for that person to get to use an environment where the fundamental unit of work is source code. But I think there is an opportunity by creating an environment that has a lot of inherent advantages, things like being able to build interactive web applications, to have really great data visualization libraries, all these things, that I think we can attract people, maybe like your son, who have no background in computing at all, or maybe who do a form of computing that's less robust, like using tools like Microsoft Excel or SPSS. I think that we can bring this rigorous methodology of expressing data analysis in code, which is fundamentally, it's automated, it's reproducible, it's inspectable, it's shareable, it's diffable. There are so many advantages to code, but there's a big gap that people have to get over, and I think we have a chance to get a lot more people over that gap and say, if you want to do the best possible data analysis, you're motivated to get over that gap. And I'm really encouraged by the fact that the Coursera course is able to teach this curriculum, this content, to people with no previous background in computing, and it works. And I've heard of stories of high school students being taught this stuff, and it works. And certainly lots of undergrads. And so I think there's a chance to get a lot more people doing a lot more reliable, kind of deeply correct data analysis. So
when I started programming, I started on a Sinclair Spectrum that you booted up, and you had just the basic, you had the REPL. That's literally how I started. And when I tried to get younger generations involved in computer programming, one of the things that was difficult was that it was almost impossible to cover the gap between you're typing in 3 or 4 lines of code. Well, how does that make Windows systems and environments and servers? It was impossible to take them from I'm writing hello world to this is the same building blocks that make every piece of software. I think RStudio is interestingly positioned that it is yet again one of these nice encapsulated instant environments like Logo, like Basic, where the moment you push enter, the world has changed. Reality has changed. You can see it represented. Was that a conscious decision?
I think that's our hope. Is very much that's the world that we could help people see, and like you said, it's a data analysis environment, right? It's not just I write a line of code and it returns a value and then I do something with that value. It's I write a line of code, I see a graphic, right? I write a line of code and some data is transformed and I can see that transformation instantly. So I think I would also say that I don't know if your son plays Minecraft.
He does.
But the Minecraft command line, I actually think, is going to have a big influence. There are lots of kids, I see 8-year-olds and 9-year-old kids, and now they all know, go right to the command line and start manipulating the world. And it's very natural. It's very, very natural. And it's the same sort of experience. Oh, I just did this and something changed. I did this and an animal appeared. I did this and it started raining. You know, and I actually think that Minecraft, in a way, it's subversive in that there's a lot of computing in it.
Yeah.
You don't see it right away, but I'm actually optimistic that more and more people are gonna be exposed to computing in this way, and it'll seem more natural to them.
You know, I'd never thought of that, but that's really funny that there's this entire generation of computer users that never had the command line.
That's right. That's right.
The WIMP interface.
That's right. Yeah.
And yet, you know, people in our generation.
Yeah.
We started with the command line. The command line is our lingua franca, and we understand that to truly interact with the computer, you have to do it at that loop. Then you have this window of users that never experienced that. And now what you point out is that it's possible that this very next generation has sort of returned to these
They may have. It's really amazing to see an 8-year-old, you know, they're up arrow through their history and they're this command and that command, and it's wonderful, and and people can do it, you know. It's not an alien thing in the least bit, and it's in a way it's actually very simple, right? It's if I have the space of 1,000 commands and all of them are I just type. Think about navigating 1,000 commands in a user interface. It's a nightmare. So it's actually simple.
Yeah.
So
you've mentioned reproducibility before.
Yeah.
I happen, you know, my personal bias is that reproducibility is one of the great societal problems.
Yes. Yep.
And that's something that really your organization is between Knitter and Markdown and RPubs and all that. You guys are really addressing reproducibility. Can you talk to me a little bit about that?
Yeah, I think it's helping people do good science, great science, right? Yeah. It's basically saying the right answer is that the data analysis I do can be reproduced. That's always the right answer. It's the right answer, as I said, for automation. It's the right answer for integrity. It's the right verifiability, inspectability, sharing. Okay, but there's more friction, there's more steps, there's more things in the workflow, and so I think we definitely have a desire to, first of all, smooth that workflow as much as possible, but then also make the side effects of that incredibly attractive. So the fact that I can create a report that's easily publishable to the web, well, you know, we say, well, you can do that. In order to do that, you have to work in a little more sound manner, and we want to encourage that. You know, and so we want to build tools. I think we want to build an environment that's really wonderful to work in, but there's sort of a cost of entry, which is that you have to do real computing. You have to work reproducibly. So,
one of the things that really attracted me to your approach to reproducible research and just reproducibility is that it's beautiful.
Yeah.
The output of, especially with the latest release of RStudio, which I think happened very recently.
Yeah, last week. Yeah.
I mean, when you push that knit PDF button or that knit HTML button, the output is a beautiful thing.
Yeah.
And that's something that I think has been historically ignored by a lot of computing types. Do you ever think about how beauty plays into it?
Absolutely. Yeah. We want the end result of working in this environment to be extremely attractive, right? And that's a motivator for people. It motivates. If people say, "Well, how did you do that?" Well, this is what I did. Well, I want to learn that, you know. And so, absolutely.
So RStudio is I think it's a technological marvel. Is there any particular, you know, I don't know how involved you are with the actual software component of it.
That's all I do.
Okay, that's fantastic.
All my work is working on RStudio, and I'm still the lead developer on RStudio.
Really? That's really awesome.
Yeah.
Is there a particular design decision that you made, or is there a particular philosophy that you've approached that you're really particularly proud of, that you want to highlight, that we made this choice and it has paid off in spades?
I think the decision to use the web make it work on the web first was really important. I mean, we from day one, in fact, the product started out as a web product and then became a desktop product.
Really?
So I think to go back and do that wouldn't happen, right? There'd be so many things you'd have to do differently. So I'm very pleased with that, and I wasn't certain that we could build a high fidelity, high productivity, enough user interface with the web stack, but we have been able to. There was some uncertainty, so there was a little bit of risk in that. Sure. But I'm glad we took that bet, and that, it continues to, the interesting thing is when we started out, it actually was only ran over the web, and sort of a lot of people said, I don't understand why I would ever want to do that, I don't get it. So we said, all right, listen, we don't want to have debates about web versus, so let's make it work on the desktop. And then I think when people first were adopting it, it was 99% of people were using it on the desktop. It's simple, it's compatible with what they're already doing. I think we've seen more of a return, more people are interested in running it over the web. So, especially in a lot of larger environments, it's definitely what people are doing.
That actually mirrors. So my personal experience with RStudio was I downloaded it onto my desktop. I played around with it. I told folks at work, this is a really productive thing. I'd like to have a bigger computer. And they found some 64-core server somewhere.
Exactly.
They put it in a rack.
Yeah.
They said, put RStudio server on it, and I now have the exact same IDE. Only difference is I have access to 64 cores.
So that was the original, what we thought could be really cool, but it takes a while to, there's too many things, there's too many steps, So first, oh, I can use this with my local version of R. It can enhance my work right now. So that's a great first step for people. But, so anyway, I think that was a big thing, and then I think the work we put into R Markdown and reproducibility and creating that system has really paid off. We didn't know when we started would people go for Markdown, where it creates only at that time only web output. Would that be okay for people? And so that has worked out very well. We didn't know. We could have just fallen on the floor and people would have said that's interesting but not useful to me. So
well, with the adoptions, particularly in the Johns Hopkins Coursera courses, I mean, I have to do the peer grading. And it's really pleasant to see that literally thousands of people from across the world are getting it. They've gotten R Markdown. They've gotten reproducibility.
I will say there was going back to teaching. A lot of the initial users were teachers, and they were actually at the time trying to teach their students SWeave, and that really has a lot of parallels. It's the same sort of system, but LaTeX is a steeper learning curve, and they were frustrated by that. And I think part of R Markdown was designed to address the needs of those teachers. They want students to work in this way that you can not only see what they thought, you can see what they coded, you can see what the results were, and again, that it's something that everyone can get. So
here's a philosophical question. So one of the things that I love about R Markdown and the entire cognitive model is the reproducibility. But one of the things that I've noticed is that it only captures your final intent. One of the things that it does not capture is the process of exploration.
That's true.
And all of the wrong turns that you've taken.
That's right, yes.
My first question is, do you think that's a valuable thing to capture? And second is this something that you think you may look to extend in the future?
It is clearly a valuable thing to capture. It is a very, very, very difficult thing to capture. One approach that people have thought about, again, working within in the textual realm, is to use something like Git, and basically every time you save, we're going to change. That's going to be a commit, and so that we actually can see all the different things that you did. And one of the problems then is navigating that. What is that actually? What state was I in? What does that look like? It's a very hard problem. So, but it is an important thing. I don't know how to easily address it in today's toolbox.
You're relatively new to the culture of R. I mean, you've been around for 6 years. R's been around for 30 years. Is there advice that you'd give the community or the culture? Is there something you take away from it that you think is particularly useful or valuable?
I would say, I would echo actually something that John Chambers talked about in his keynote today, which is to understand that especially, again, this is a lot of the new people coming into R, and they're struggling with what is R like as a programming language, and how can I bend it to do what I'm accustomed to. And I think to understand that R is an interactive data analysis system that's really ideally designed for that, and that that a lot of the secret to making R successful in the future is doing what John suggested, is interfacing R with the rest of computing. And so I would say to people who are trying to write R, high performance R code, they should look at writing that code in C++. For people who are trying to integrate R with distributed systems, look to interfaces that people have developed and are developing. So I think understand that what R is good at, it is extremely good at. It's world class at what it's good at, and understand that as you said, R it can be a portal and a gateway into so many things, and that's a way of working and thinking that we should all embrace, and not try to get R to do too many things it wasn't designed to do, and give it world-class interfaces sort of to all the rest of computing.
Well, is there anything else you'd like to add that we haven't talked about?
We've covered a lot of ground. I think it's great to have the opportunity to talk about all this stuff. I care about it more than anything.
Clearly you do. It's a real pleasure. Thank you very much.
Thanks. All right.